Okay, this is question 7 from January 2022, the P3 paper. If you look at it, we can see quite clearly that this question is a functions and graphs question. It's actually, to be specific, modulus functions when we're looking at it. So let's get started. As typical with one of these, what it does is it actually gives me the function there and then asks me for this specific point. The easiest thing to do is to actually draw out this function and see what we get. Now, what I'm going to do for this question is, in order to explain it to you guys, I'm going to do more work than I would necessarily write down. This is only a 2-mark question, so I wouldn't spend ages and ages like I'm doing to build this up to you, but I'll show you the method that I do, and I may as well leave it as part of my answer on the screen here. So if I'm going to try and get this modulus half 2x plus 7 minus 10, I'm just going to build it up. So the first thing I do is I draw a graph out, draw a set of axes out, and I say, okay, right, what does y equals 2x plus 7 look like? Well, y equals 2x plus 7 is going to look something like that. It's a straight line and it hits at 7. What's this value here going to be? If we've got 2x plus 7 equals 0, 2x equals minus 7, so x equals minus 7 over 2. So I've got, in my initial graph, those 2 points, so I don't need all that, but that's what y equals 2x plus 7 looks like. So more important than that, I want the modulus of that graph, and what the modulus function does is it basically means that all these negative values will be flipped over and will become their equivalent positive values, like a reflection in the x-axis. So if I'm doing that, then let's just use my iPad. What I can actually now say is that's what the modulus of 2x plus 7 would look like. Okay, that's what that one looks like. Then for part B, then the next version of it, would be simply to take account of what the half does to it. And what the half does to it, if we draw this thing back in, rough and ready, because obviously we wouldn't have any of this on the actual answer that I'm going to be given. If this is what that graph looks like, and we then want to say y equals half of that, what this half here is doing is taking every y value and dividing it by 2. So this value is now going to be here. This value is now going to be here. This value is now going to be here. The only value that's unaffected by any of them would be this value. That doesn't get changed. Most important one is this one that was at 7 here would now drop down to 7 over 2. So this one would stay as minus 7 over 2. If we have a quick look at this, we can see that the gradient of this line here should be the same as the gradient of y equals x, and I might use that a little bit later on. But okay, so that's the what y equals a half 2x plus 7 looks like. If I then want to drop this down by 10 units, and again, as I said to you, I'm showing way more working out than I would if I was actually doing this. But in terms of just explain it to you guys, if I've got this graph now and I drop it down by 10 units, that's what I'm going to end up with. So let's just copy that one, put it on this one here, but then drop it down by 10 units. So if I drop it down by 10 units, what do we now get? This is our answer here. We get that this is minus 7 over 2, and that would be minus 10 there. If I'm taking 10 units off of that one, just for a little bit later on with the work, I'm interested in that being minus 13 over 2. And as I say, because we said that the graph had a gradient of 1, those 2 points will become more important just for later on in the work. But in terms of finding out what vertex V is now, vertex V is nice and easy. It's minus 7 over 2 minus 10. So just to make absolutely clear, there's a lot more work there than I would actually put on my answer if I was doing it under exam conditions, but that's more of an explanation of where we get that answer from. Part B then, make this a bit bigger again. Part B talks about solving the equation. Where does a half modulus 2x plus 7 minus 10, where is that as an inequality actually, where is that greater than or equal to a third x plus 1? So what I need to do for that is to find the critical points on this graph. Just do that in a different colour. Where's the third x plus 1? What's that going to look like? Well, if it's a third x, then my gradient is going to be much less steep. It's going to look something like that as a third x. And if it's a third x plus 1, going through and hitting at a coordinate of 1 there, all I'm interested in, I don't need to have this red line on, I'm going to get rid of it in a second, but it's just when I'm trying to find my solution, I'm going to get a positive value for x there and a negative value for x there. And actually, if I'm doing those bits, I want to know when the purple graph is bigger than the red graph. So actually, I might just extend that on a bit. I'll leave this on for us. Take it off later when I'm actually doing these solutions for myself. Is I want those two critical values, which I'm going to work out now. But once I have worked them out, I want this region here and this region here. That's when the purple graph is bigger, and that's when the purple graph is bigger. So I'll leave that on and we'll come back to it at the end. So I'm going to talk, this would actually be what I'll be writing down though, this time, critical values. So that's going to be where a half modulus 2x plus 7 minus 10 equals a third x plus 1. And now I've just got to actually solve that. So I'm a little bit too small. Got to solve that then. So if I'm going to be solving it, what I tend to do is to first of all try and get just modulus 2x plus 7. So in this case, I'm going to say half modulus 2x plus 7 is equal to a third x plus 11. We're taking the 10 over to the other side. Double everything up. So modulus 2x plus 7 is equal to, multiplying everything by 2 here, 2/3 x plus 22. Now this is one of those occasions where I actually do two bits of calculating at the same time here. I can solve 2x plus 7 equals 2/3 x plus 22, and then I can also do the negative of that. So minus 2x minus 7 is equal to 2/3 x plus 22. That's how we solve these modulus equations, and I'll get two values, and from what we said previously, I'm really hoping one of them's a positive and one of them's a negative. So let's do that. For the left hand side, I'll take that over there and I'll take that over there. Just quite quickly, the video's already long enough. So 2x take away 2/3 x leaves me 4/3 x is equal to 15. Brilliant. So that gives me x works out to be equal to 45 over 4. And with the other one, we'll take the 2x over to that side, and we'll take the 22 over to that side. What's that going to give me? That's going to give me minus 7 minus 22. Okay, that's going to be minus 29 here. Make that clearer. Is equal to 8x over 3. Oh yeah, well I wanted a negative, didn't I? We were just saying that a second ago. So x works out to be equal to minus 87 over 8. Not the neatest of answers, but that's absolutely fine. So going back up to what we just said a moment ago, for my inequality then, I want to be bigger than the positive 1, but less than the negative 1. Okay, so if we do that, our actual answer is going to be x greater than or equal to 45 over 4. Move that over a bit. Greater than or equal to 45 over 4, x less than or equal to minus 87 over 8. Okay, on to the last part, part C. And what we want to do for this one is y equals the modulus of fx. What I want to do is to actually be able to draw that one out. I think I'm just going to redraw my graph rather than trying to copy and paste anything across here. So what do we know about my graph? And I'm using some of the piece of information that I already had from before. So I know my graph looks something like this as the actual original graph that we had, and we knew that this value here was 13 over 2, which means that this value here was minus 13 over 2. We know that this value there is minus 7 over 2. This value was minus 10. What we don't have is that value there, but we can work that out because, again, using the idea that this is a gradient of y equals x, so what we're going to do, if I'm going up 10 units there, then I can go across 10 units there because it's a gradient of 1. It's a gradient of minus 1, but it's a gradient of 1. It goes up and across the same amounts if the gradient's y equals x, if it's that curve. So take 10 more of that. Right, that's going to be minus 27 over 2. And now what I've got to do is to actually do the modulus of this graph. So the modulus of this graph, what that then means, just as we said last time, was that actually then all those values, move that on a bit like that, the negative values that we've got underneath, they've all got to go, and they've all got to go, so I'm going to end up with this W shape here. Let's actually try and make it look like I want it to look then. So my final answer is that now this value here is going to be 10 this time. Oops. That value there is now going to be 13 over 2. And then let's just check and see what they actually asked for in the question. It said stating the coordinates of the local maximums and minimums. So as we're actually going through, yeah, I've got, goodness sake, I've got that one there is minus 27 over 2. I've got that one there is 13 over 2. So it might be worth just saying that this point here is minus 7 over 2, 10, just to make it absolutely clear to the examiner. Right, that's that one done. Hopefully that all makes sense. Long question.